Hi. So in this video I want to talk about gain staging. This elaborate sounding word and also my whole setup here might raise a few questions here and there. Such as, what even is gain staging? And what are those? And even more important, why is my microphone so far away? I think it's time I give you some answers here before we actually talk about gain staging. So, why do I have this microphone this far away? I want to give you an easily audible example for room noise. This is what you hear then. That is room noise. And by the way, since we are at it, this is why I have these displays, these representations of what's actually happening here. Right now you hear, well, the room sound, or the room noise, if you will, and the signal, which is my voice. Now we have only the signal, and literally no room noise. Because, well, this is post-processed in a way that I have a noise level that is below the noise floor of a 32-bit signal. This is utterly and totally inaudible. Anyways, so this is why I have these visuals. I want to give you examples. I want to give you examples for different kinds of noise, which is what this is for. And I want to give you an example for headroom, which is this is for. Before we talk about that, let me explain what headroom actually means. The headroom is pretty much the difference between your voice and the loudest possible signal to record. As you can see in this graph right here, we have about 24 decibels headroom. Sometimes I'm getting as loud as minus 18 decibels, and sometimes I'm getting as quiet as even minus 30 decibels. This is what headroom means. If you go lower than, well, 0, then you have as much headroom as the number says. For example, at minus 24 decibels, you have 24 decibels headroom. Right. So these are the graphs. And now for the big one. What is gain staging? Let's put it elaborate. Gain staging is the art of setting your signal ideally. What is ideal? Well, ideal is really a trade-off if you think about it. Because there are two things that you want to do which don't really work together. Not like that. On the one hand, you want to have as much dynamic range as possible. If you wanted, if you could, you would probably set your microphone like you can do everything from the faintest whisper until shouting your, off, right? You want to do all of that without the signal ever clipping. But on the other hand, you want to have as little noise as possible. That's tricky. Until it isn't. I would actually say, don't care for the noise. Oh, and I can already see all the microphone nerds getting ready to pounce on me. But really, I have a reason to say this. So hear me out first. In the last video, I showed how important it is to have the microphone close. The closer you have the microphone, the lower the noise level gets. And because you use less gain, also the system noise gets lower. It's not just the noise in the room. It is already both kinds of noises that get reduced. And what's more, most people cannot even distinguish between system noise or self noise and background noise or room noise. So let's start with system noise. This is system noise. How do I do this? How do I create just system noise here? I have two microphone inputs. And on one input, I don't actually have a microphone connected to it, but just, give me a second, this. See, this microphone is not plugged in. I have this connected to it. That is an XLR plug. Literally, just an XLR plug. Not quite. So this XLR plug, and I have a few of those, they have a little trick up their sleeve. And that is this. I screwed this one open. By the way, that is an XLR plug. If you never saw something like this, if you ever heard the term XLR microphone, it literally means it has this plug. That's it. There's no magic that makes XLR microphones better. It's mostly more like the price. But anyways, so we have this XLR plug and it has a trick up its sleeve. This. There's a little resistor soldered in between the pins 2 and 3. This resistor makes the preamp inside of my audio interface behave as if a microphone was connected. See, you cannot simply unplug your microphone and listen to the noise, because the moment you unplug your microphone, the impedance that is on the input of the audio interface, on the microphone input, is going to be infinite. And as such, it's going to be way louder than if you had a microphone connected. So this is where these come in. I have this connected because it demonstrates a noise level. It's not quite the right impedance, because actually you would need to have something that is the same as the microphone, and that would mean, in this case, with this microphone, the Rode Procaster, 294 ohms of impedance, I think. Anyways, it doesn't really matter. So I'm using this so you can hear noise. System noise. That is, you can hear it. Right? Well, it might depend on the equipment that you use. For example, I'm using a rather good headphone, a rather good pair of headphones on a rather good audio interface. All of this together is already quite expensive. Let's put it this way. But yeah, for me it is not a problem to hear this. That being said, it is still quite quiet. And this is why I would say, from the noise perspective, gain staging doesn't matter. Just from the noise perspective. You can hear this noise. Barely. If you have good equipment. But now let's switch over. This is not even close. This is so much louder then, well, we don't need to argue here. The noise in your room, if you have just 10 centimeters, 12 centimeters between you and the microphone capsule. And if you ever tried that, that is not much. Now the noise level might be quite, well, audible. But yeah, that is room noise. That is not the system noise. And if you want to fiddle with, setting just right everything so you don't ever clip and you have as little noise as possible, to get this trade-off right, yeah, you can fiddle a lot of time with that. I did it myself. But really, it is not that important. Because, well, I demonstrated it. You can barely hear this. And, well, let's say you can hear this. Normally, you're not alone on the stream. There's always something happening. There's either music in the background, or you have a game in the background running that's also creating a noise level. Well, I say noise level, but actually, well, background sound. Let's give us a little example with music here. Oh. Sorry, that was loud. But yeah. Now you might have a problem to actually hear the noise. Because, well, the music is louder than the noise. By far, actually. It renders the whole argument about system noise completely obsolete. Also, you do post-processing anyways to get rid of the remaining noise. So even if you had a perfectly quiet room, and nobody does, but let's say you had it, even then, if you have this low noise level to remove, that is the easiest job you could ever have. Trust me, this is worse. And funny enough, with the music running, even the noise from my room is probably barely audible. But yeah, there we go. Headroom is much more important. The noise level doesn't matter. For the sake of this tutorial, I'd say try to hit about minus 24 decibels. If sometimes you get louder, let's say minus 18 or even minus 12 decibels, I think it is fine. But yeah, minus 24 should be your average level. And as you can see, your signal on the output can still be very loud. And it won't be much work to do that, even without clipping. I will show that in future videos. In the next video, I'm going to talk about how to do the actual gain staging on both an audio interface and on a USB microphone. It is going to be a little bit different on the two, and that is why you might want to watch both parts of that video. But yeah, this is going to come. Thanks for watching. Bye.